Great, welcome back. Overall, I hope you didn't find that too tough, with the exception of some of the bonus challenges. Hopefully you've now set up a system within your project that triggers explosion sounds to be played whenever a shell from a tank hits something in the game scene. Now it's time to compare your results and your method of implementing the sounds to mine. Okay, so to start, I'm going to find the object in question that we want to add sounds to, which is the shell object. So if I go to Assets, Tanks, Completed Assets, Prefabs, I can find the prefab file of our shell object, select it, and open it. Great, now the first thing I need to do is learn a little bit about this object and how it works. Obviously my goal is to tell a sound to play whenever this shell hits something, so I need to know how it recognises that it's hit something. Looking through the components attached to this prefab, I noticed that this object has a capsule collider component that has also been marked as a trigger. This means that there is a good chance that the object is set to do something, most likely explode, apply damage to a tank if it hits one, and remove itself from the scene after it recognises that something has entered the trigger area around it, created by the collider component. And if that's true, then that's good news for me, because we know that I can use a simple onTriggerEnter function to trigger the explosion sound to play with. But it doesn't hurt to test this idea first. If I was working on this game with the team who developed and programmed it, I could simply ask them to explain to me how their shells are designed to recognise collision, which I could then use to help myself implement my sounds. But sadly, in this instance, I don't have that luxury, so I'm sticking to my test. So the first thing I'm going to do is make my way to my audio scripts folder and then create a new script. Call it something like shell audio and then attach it to the shell object. Once the script has finished compiling, I can open it up and edit it. Now inside the script, all I'm going to do is test to see if the onTriggerEnter function will run whenever the shell object hits something. So I'm going to start by removing the start and update functions and then replacing them with the onTriggerEnter function. Then after that, I'm simply going to add the debug.log function. I'm going to enter a message into this function, such as trigger queued. Now to test to see if the onTriggerEnter function will be called whenever the shell hits something, I'm going to save this script and play my game. So I'm going to go back into Unity and first save my prefab, open up the console tab, and then press play. Now what I want to see is my message appear only at the exact moments that a flying shell collides with something in the game. Okay, so now if I fire 1 or 2 rounds at a time in the game, the message appears. Great! Now it's always good to be as thorough as possible when testing game mechanics, when trying to learn about how they work. We wouldn't want to overlook an instance in this game where a shell, for whatever reason, intended or not, doesn't cause the onTriggerEnter function to be called. So in the case of our tank shells, it's important to test both tanks to make sure the message fires. And it does, great. We can tell that the message is being triggered as the number to the right of it increases by 1 each time a shell collides with something. But to make it clearer, you can also uncheck the collapse button so that each message appears separately. We also want to test to see if firing shells at different parts of the environment makes a difference, or even firing shells at each of the tanks prevents the message from appearing. So make sure to test those things too. But to me, I'm happy that the message will appear no matter where the shell lands. Okay, so first things first, I need an audio source component. Now, as we've already discussed, we know that we can't have an audio source component attached to the parent object complete shell, because as soon as the shell collides with something, this object is detached from its children and is removed from the game. So instead, I'm going to add an audio source component to the complete shell explosion object, because we know that this object won't be removed as soon as the shell collides with something. Next, I need to give this source an audio clip to play. So I'm going to click the little dot to the right of the audio clip field and select my clip, which is shell explosion. Now I don't want this to play on awake, so I'm going to uncheck that toggle box. And just like our power-up objects, I also want this to be 3D. So I'm going to come to the spatial blend option and set it to 3D. For the exact same reason as the power-up object, I also want to make sure there's no volume attenuation on this audio source. So I'm going to scroll down to the 3D sound settings, change the volume roll-off from logarithmic to linear, click on volume at the bottom of the graph, and then finally make sure it never goes below 1. So if I place that there, readjust the position of that angle, and there we go. So now we won't hear any changes in volume, but we will hear changes in where the sound will be played in the stereo field, depending of course on where the shell explodes relative to the camera. Great, I'm now happy with all of these settings, so I'm going to save my prefab. And I think I'm going to jump back into my script. Okay, so I know that there is no audio source attached to the complete shell object that this script is attached to, but there is one on the child object called complete shell explosion. So I'm going to need to reference that component in order to play a sound with it. So I'm going to create a private audio source variable, which I'll call source. Then I'm going to add the start function back, and inside of that I'm going to give my source variable a new reference to hold. To find that reference, I'm going to get a component from one of the children objects attached to this one that has an audio source component attached. So I'm going to write get component in children and then search for an audio source component. Finally, inside of my onTriggerEnter function, I'm going to remove my debug.log function and tell my audio source to play. Now all that is left to do is save this script and jump into Unity to test. Okay, so if I now fire a shell, we hear a small explosion sound. Great! Okay, so it's time to look at the bonus challenges. Now the first challenge we've already completed by using the onTriggerEnter function to play our shell explosion sound. So we can move straight on to bonus challenge 2, which asks us to randomly modulate the pitch of a sound that we're playing. So to do that, the first thing we need to do is access the pitch property of our audio source. I'm going to add a new line right above where I've told my audio source to play so that I can modulate my pitch just before the sound is played. Then I'm going to write source.pitch. Now I want to set the pitch to a new random value, and to do that I'm going to use the random.range function. So I'm going to write random.range with an open and closed bracket. Then to use the range function, I just need to give it 2 float values for it to pick a random number between. Now I know that the pitch of an audio source ranges from -3 to 3 and has a default value of 1, so to randomize it around its default value, I'm going to use the numbers 0.5 and 1.5. Now of course here would be a great place to stop and test my new edits, but I'm pretty confident that this will work, so I'm going to keep moving on with the bonus challenges for now. Bonus challenge number 3 simply asks me to implement a way of quickly changing the values that I randomize my pitch by from within the Unity Inspector tab. So to do that, I'm going to need some float variables to represent the values I want to give to the range function. Those variables will then become serialized so that we can interact with them outside of this script. So I'm going to declare the first of my 2 variables, but first I'm going to include the serialized field attribute at the beginning. Then I'm going to create a private float variable, call it min, and set it to 0.5. I'm also going to copy this new line, paste it back into my script, and just change the name to max. And also change the value of this new variable from 0.5 to 1.5. Now all I need to do is replace the values I gave the range function with these new variables. And now I can save my script and move on to the next bonus challenge. Now starting at bonus challenge 4, things start to get a little bit trickier. We're asked to create a toggle option for the script within Unity that allows us to turn the modulation of our pitch on and off. This is something we haven't yet done in this course, but we have been shown how to use the tools required to create one. So to complete this challenge, the first thing I'm going to need is a Boolean variable to use to control our toggle with. I'm going to then create a new variable above the min and max float variables. I'll make it a serialized private Boolean variable and call it modulate pitch and initialize it as false. Now if I quickly save my script and jump back into Unity and wait a little bit for my script to compile, we should see what the new Boolean variable will look like within the inspector. You can see a tick box has appeared next to where it says modulate pitch. Great, so what I want to do now is use this tick box to control whether or not our random range function will modulate the pitch of our audio source. Okay, so now because I only want the pitch to be randomized if modulate pitch is true, I will need to use an if statement. So inside of the onTriggerEnter function, I'm going to create an if statement. Then I'm going to take the line where I set a new value to the pitch of the audio source, cut it with Control X or Command X on a Mac, and then paste it into the body of my if statement. Then inside of the brackets, which remember is where we set the condition of an if statement, I'm going to simply write the name of our variable, which was modulate pitch. Remember that when you just write the name of a Boolean variable within the condition brackets of an if statement, you're basically asking your if statement to check to see if that variable is true. Another way of writing this would have been to write the name of the variable, followed by two equal signs and the word true, like this. There's no real difference between using either method, it's just whichever you prefer to write. Now all I need to do is save my script and take a look at it in Unity. Okay, so the first thing I'm going to do is set the modulate pitch toggle variable to true by ticking the box next to its name. I'm also going to increase the max value to 3 so that we can really hear the change in pitch modulation when testing. The last thing to do is save the prefab, and then I'm ready to test. So now if I fire a couple of shells, we hear that the pitch of the shell is different every time. But if I move outside of the game, going to the prefab of the shell object and toggle my modulate pitch variable off, save the prefab, and then return back to my game, I should now hear my shell explosion sounds at the same pitch every time I fire it from my tank. And that's exactly what happens. Brilliant, so we know it works. The final bonus challenge asked us to randomly modulate the cutoff level of a low-pass filter effect. Now, if you remember back to lesson 4 in module 1 of this course, we briefly looked at some of the other audio components that Unity provides for us. To apply one of these effects to an audio source, you simply attach it to the same game object. So if this challenge asks us to modulate a low-pass filter, then we will need to add it as a new component and attach it to the complete shell explosion game object that has our audio source. So that's what I'm going to do. I'm going to click add component, type in low pass filter and add the component to my object. Now the audio low pass filter component has two public fields for us to interact with within the inspector. The first is a cutoff level, which allows us to set in hertz at what point we want to cut off any frequencies from our sound that are higher than the value we give it. The second allows us to adjust the intensity of the resonance of that filter. These two fields shouldn't be too unfamiliar to us, as they're pretty common with most EQs you would find in a standard DAW. You may have also noticed that if we take a look at the bottom of the 3D attenuation graph in the audio source, that we now have the option to control the cutoff of our low pass filter based on the distance between the audio source and our audio listener. However, we're not interested in adjusting the attenuation of the low pass filter, we only want to modulate it, so we won't be making any changes here. Now, in order to complete our bonus challenge, I will need to find a way of randomly modulating the cutoff. So I'm going to go back into my script and take a look at how I might achieve this. Okay, so as we know, whenever we want to access anything from another component, we need to get a reference to that component and store it within a variable inside our script. This is just like what we had to do with our audio source. So at the top of my script, I will need to create a new private variable of the reference data type that I am trying to access. Remember that the data type will need to be the same as the name of the component itself, so that will be audio low pass filter. Then I can give my variable a name, so I'm going to call mine filter. Now remember, this variable is currently empty. What I need to do is give it the specific audio low pass filter component that I would like to access. To do that, I would normally use getComponent if the component was attached to the object that my script is, but just like with the audio source, it is attached to a child object. So I will instead need to write inside of the start function filter equal to getComponent in children audio low pass filter, just like that. Now that I have access to the component, I just need to tell its cutoff property to randomly modulate. So inside the onTriggerEnter function, I will write the name of the variable that contains the reference to the component that I wish to access, which of course is filter. Now I need to follow this with .cutoffFrequency, but before I do, I'm just going to write .cut, because I want you to notice what Visual Studio displays for us. As you may have noticed by now, Visual Studio is able to tell you what fields you can access from within a reference variable like ours has, thanks to its IntelliSense feature. Right now it's telling us that there are two cutoff fields, one called cutoff frequency and one called custom cutoff curve. Custom cutoff curve is used if you ever need to find out what the cutoff has been attenuated to by the audio source that we took notice of earlier. So for example, you may wish to know what the cutoff has been set to by the audio source's attenuation graph when an object playing a sound has moved to a certain distance from the listener. But if you just want to access the cutoff frequency without regarding distance attenuation, you simply use cutoff frequency. So that's what I'm going to write. Then I'll follow this with an equal sign to say that I'm setting a new value for this field. Now all I need to do is once again use the random.range function in order to give it a random value within a specified range. Like most low-pass filters, the cutoff ranges from 10 to 22,000 Hz. For the purposes of simply testing this script, I'm going to set my range between 50 and 2,000 Hz, making the modulation clear and obvious for us to hear. The last thing left for me to do now is save my script and test it in Unity. So after waiting for my script to compile, I can now save my prefab and now play my game. And if I fire a few shells from either tank, we should hear a drastic difference in the frequencies we're hearing. Okay, so here we go. Great, the explosion sounds are now a lot more muffled because of the cutoff effect. Not only that, each one also sounds slightly different. Some are more muffled than others because I'm modulating the cutoff property for each shell as soon as it hits the ground. And with that, I've now just completed the final bonus challenge. And that concludes the challenge for Module 2, as well as the first challenge of this course. So how did you find it? Did you complete many of the bonus challenges? Did you get a bit creative and add your own functionality? If you did give the bonus challenges a go, give yourself a score out of 5 to get a rough idea of how well you did. Like I said at the beginning, some of these were a little bit challenging, so don't worry if you weren't able to get all 5 out of 5. Remember, the main point of this challenge was to just get you to work with the things we've addressed so far in this course, such as basic functions, reference variables, assigning values to the properties within the audio source component, and using functions from classes in Unity's API. It also doesn't matter if your script turned out completely different to mine. For now, our motto is, if it works, it works. But no matter what your score was, I hope you enjoyed this challenge. Be sure to expect more as we progress through the course. And with that, you've also finished Module 2 completely. You should now feel a little bit more confident with interacting with audio sources, as well as some basic ways that you can modulate your sounds. As always, there's plenty of extra resources at the end of each lesson, including this one, if there was anything you didn't quite understand, so you can always go back and check them out. You can always get in contact with myself if you need a little bit of extra support, but if you're happy with everything covered in Module 2, it's time to move on to Module 3. So once you're ready and you've given yourself a nice break, I'll see you over there.